Okay, so this video is meant for Algebra 2. We have a quiz covering the first part of Chapter 5 on Thursday, and here are 6 problems to help you prepare for that quiz. First, we need to determine the end behavior of this graph. So here's our equation, and the first thing is to put it in standard form, okay? So standard form would be highest power of x. So this x to the 8th is the highest power, so negative 9x to the 8th goes first. And then the next highest power is x to the 5th. So then the negative 6, x to the 5th is second. And then the last term is negative 3. So now to determine end behavior, the first thing you do is you look for the leading coefficient. And that is the first big number, negative 9. And because it is negative, your right side is going to go down. Negative means down, positive means up. So then we look for the degree. And the degree is the exponent of the leading term, that's 8. Now, the question is 8 even or odd? 8 is even. Even means same. So even equals same direction. So if the right side's going down, so is the left side. And that's the end behavior for this graph. 2. Determine the degree of the polynomial function with the given data. And this problem is all about the differences, if you remember. Difference of, and it's the y's. If you notice the x's are in order, so that's fine. So we need to determine the common differences of our y's. So what I will do is over here, I will rewrite the y's. Negative 15, negative 9, negative 9, negative 9, and negative 3. And what we're going to do is we're going to find the first difference. And to find the first difference, we subtract negative 15 minus negative 9. That becomes plus plus. Negative 15 plus 9 is negative 6. And we do the same thing all the way down, right? Negative 9 minus negative 9 is 0. Negative 9 minus negative 9 is 0. Negative 9 minus negative 3 plus plus is negative 6. So we notice the first differences are not the same. Okay, so now we go to the second difference. And again, we do the same thing. Negative 6 minus 0, that's negative 6. 0 minus 0 is 0. 0 minus 6. 0 minus negative 6 plus plus, that's a 6. So again, second difference is not the same. We do the third difference. Negative 6 minus 0 is negative 6. 0 minus 6 is negative 6, and hey, they are the same. What this means is that this is a third degree polynomial, and the name of a third degree is a cubic. And I don't think I have you memorize those names. If you do, you have your notes at the second half. But the degree is the important. Third difference, third degree. All right. So that's the common differences question. Okay. 3. Write a polynomial in standard form with the given zeros. So recall that if these are the zeros, then the factors have the opposite signs. X plus 5, x plus 5, and x minus 1. And now we need to distribute, multiply, whatever you want to call it, all 3 of these out. You work 2 at a time. Let's go with the last 2. I like to have this first one available the second time around. So x goes to x and negative 1. X times x is x squared. X times negative 1 is negative 1x. 5 goes to x and negative 1. 5 times x is 5x. 5 times negative 1 is negative 5. The middle terms will combine x squared plus 4x minus 5. Once you get that simplified, put that in a parenthesis and bring down the term not used, x plus 5. And now, let's distribute. Again, the x goes to all 3 things, the x squared, the 4x, and the negative 5. X times x squared is x cubed. X times 4x is positive 4x squared. X times negative 5 is negative 5x. And we do the same thing with the bottom. 5 goes to everything. 5 times x squared is 5x squared. 5 times 4x is 20x. 5 times negative 5 is negative 25. And now any like terms? Yes. X cubed by itself, but the 4x squared and the 5x squared make a 9x squared. The negative 5x and the positive 20x make a positive 15x, and the negative 25 just comes. And this is what my function f of x equals. So again, in a problem like this, remember that the factors have the opposite signs of the zeros, and when you multiply 2 at a time, 2 at a time. 4. Find the zeros, state the multiplicity, and remember, we're going to graph this. It's going to say graph. So, to find the zeros, set this equal to 0, right? Because the zeros are when y is 0. And now set each parenthesis equal to 0. So 2x plus 3 equals 0, x minus 1 equals 0. And solve. First one, subtract 3, 2x equals negative 3, divide by 2, x equals, and this is negative 3 halves or negative 1.5, whatever you would like. Okay, so that's 1. And then add 1, so x equals positive 1. There's 2. But notice that this x minus 1 is squared. So there's actually 2 x equals 1s. So this, if we're talking about multiplicity, 1 occurs twice. And then negative 1.5 occurs once. So I'm going to graph this. Here's my coordinate plane. Let's put 1 here with a dot. Let's put negative 1.5 in between negative 1 and negative 2. Assume the right side is up. I will tell you that in the problem. So in this graph, it's going to come down to the 1. And because the 1 occurs twice, it's going to bounce off. It's going to come down to the 1. It's going to bounce off. It's going to then turn back down through the 1.5. And since it only occurs once, go straight through. And there's your graph. The low point, this bounce off point, is a relative min. This high point right here, that's a relative max. I think I'll ask you to label those. Just make sure you can identify the top points are the maxes, right? This says max, sorry. And the bottom points say min. Okay. 5. All right, here we go. Find the real or imaginary solutions. So in the first problem, there are 2 terms, right? It's very important. It says equals 0, and there are 2 terms. So this is going to be a cubes problem. All right, so here's what I will do. The perfect cubes are x cubed, and 64 is 4 cubed. So when I create these 2 parentheses here and here, the first one is exactly what it looks like without the cubes, x minus 4. The second one has 3 terms. The first term is x squared. The last term is 4 squared, 16. And the middle is the product, x times 4, 4x. The signs are same, opposite, always positive. And that's the factors. So now we said each one equals 0, x minus 4 equals 0, x squared plus 4x plus 16 equals 0. The x minus 4 produces a real 0. We add 4, x equals 4. The quadratic here creates 2 imaginary solutions. We have to use the quadratic formula. A equals 1, b equals 4, c equals 16. Quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We find the discriminant over here. So b squared is 4 squared minus 4 times a is 1 times c is 16. This is 16 minus 64. That's negative 48. So now when we fill in our formula, opposite of b, opposite of 4 is negative 4, plus or minus the square root of negative 48 all over 2a. Negative 48 inside a square root means I. And then over here, I'm going to break down 48. 48 is going to be 16 and 3 because 16 is a perfect square, 4 squared. So 48 is 4 squared and 3. So we have x equals the opposite of 4 plus or minus I square root of 4 squared times 3 all over 2. The 4 will come out because it's squared in front of the I. The 4 squared is gone, 3 is inside the radical, and 2 is down below. And now, since I pulled out the 4, we can divide the 4, and the 2 by 2. And get our final answer of negative 2 plus or minus 2I radical 3, and the bottom becomes a 1, and it goes away. And there are your two imaginary solutions. So you have a real solution of 4 and 2 imaginary solutions. Okay, I'm going to do the second one down below. Let me rewrite it. I'll do orange so we don't get confused. So it says x to the 4th plus 7x squared equals 18. X to the 4th plus 7x squared equals 18. So the first thing you have to do is make sure it says equals 0. So subtract 18. X to the 4th plus 7x squared minus 18 is 0. And now this is a trinomial. There are no common factors, so we have to factor it like we would our other trinomials. Identify C as negative 18. Identify B as 7. The factors of C are 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, 6 is already there. We're done. To get a negative number, different signs, minus plus or plus minus. To get a positive 7, you need the bigger number to be positive. Minus plus, minus plus, minus plus. And now we combine. Negative 1 plus 18 is 17. Nope. Negative 2 plus 9 is 7. Yep. So negative 2 and positive 9 go in my parentheses like this. X squared minus 2, x squared plus 9. And this is factored. Set each factor equal to 0 and solve. Add 2. X squared equals 2. Square root, square root. X equals, when you take a square root, you get 2 answers, plus or minus. 2 does not break down, so there are 2 of your solutions, positive and negative, square root of 2. We do the same thing here. Subtract 9. Square root, square root. Now a couple things happen here. Plus or minus. I comes out. And now the 9 is positive, and of course the square root of 9 is 3. So this is actually x equals plus or minus 3 comes out, 3i. And there's your other two solutions. So remember, 4th degree, right? That's the degree, highest power, 4 solutions. Make sure the number of solutions equals the degree. Okay. And then the last one. Here we go. Determine the cubic function that is obtained from the parent function of y equals x cubed after each sequence of transformations. We have a vertical stretch of 3, reflection over the x-axis, 2 units up, 1 unit to the right. So recall that the general formula, y equals a, x minus h is going to be cubed because the function's cubed plus k. So what do these things mean? Well, the first two have to do with a. It's going to be stretched by a factor of 3, so a is 3. However, a reflection puts a negative in front of that 3. Okay? Vertical translation, this is k. Okay? And what this means is if you're going 2 up, that means 2. That means k is a plus 2. And then the horizontal translation is your h. 1 unit to the right, you would think of positive 1, but it really means negative 1. X minus 1 inside that parenthesis. That means 1 to the right. And we've pretty much built our function up here. Y equals negative 3, x minus 1 squared, plus 2. Oh, not squared, sorry. X minus 1 cubed, right? It's a cubic function, plus 2. And there's those 4 transformations put into this formula, into this function. Alright, hopefully this helped. You get a bonus point for doing this, so good job if you did it. Bring it in, and good luck on your quiz Thursday. Alright, thanks for watching.